Hello engineers, welcome back. In the previous video, we saw the introduction to OOPS object-oriented programming system. In this video, we'll continue to learn about it, and in this video, we'll learn about classes and objects. Okay, let's get started. So in this video, we will understand what are objects, what are classes. We'll try to get the structure of a class. We will discuss access modifiers, and we'll also discuss setter and getter methods. Okay, so in the previous video, we understood that everything is an object, right? So this building is an object, this car is an object, this park is an object, this tree is an object, everything is an object, right? So let's take a similar example to understand objects. So let's say we are taking a classroom example, okay? And we have students. Let's say I am a student and this is me. Let's say there are two other students. Let's say one more student is there, Krishna. And then there is another student. Let's say there is a girl and let's call her Sam. Okay, there are three students in our class, and these three students will have common properties, right? They all have, let's say, a roll number, and let's say they all have age. Let's keep it simple. Let's take just two properties. They can have many more like name, gender, etc. Let's keep it simple. So roll number of Uday is 1 and age is 10. Let's say roll number of Krishna is 2 and age is not 20. Let's say 11. And Sam's roll number is 3 and age is, let's say, 12. Okay. So all these three students have common properties, right? So these are common properties. So if there is a new student coming in, that fourth student will also have these two properties, right? So this bit, these common properties is a structure. You can say structure, you can call it a schema, some people call it blueprint. Okay, what does this have? This represents the common properties. Common properties. And this kind of structure, schema, or blueprint is called a class. In the OOPS world, this is a class. Okay, so this is why some people call it a blueprint, because it defines a structure. Another example for this to understand these classes is a house example. Let's say we are building a house, and before building a house, we draw a plan, right? Let's say we draw a blueprint like this. This is a bedroom, and this big thing is a hall, and we have a kitchen, and we have a bathroom, and so on, right? So this is a blueprint. But this is not the actual house, right? What is a blueprint? It's just a paper. This is not the actual house. So what do we use this blueprint for? This is like a plan. This is like a layout. And using this layout, we build the actual house, right? So this is the house. The blueprint is just a paper. So this is the class. This is not the real house. The house is here. Using the class, we made our house. This is the real object. In the same way, roll number, age is a student class. This is the student class. But actual students are Uday, Krishna, and Sam. So this is the paper. This is the paper. And these are the objects. So this is the class. Student is the class, and it defines what should each student have. This is an object, this is an object, and this is an object. And every object will follow the defined structure of the class. Okay, that's why we have classes, so that they can all have common structure, and we don't have to rewrite the structure every time for each object. Okay, so how does this look like? So the syntax of class is class. In our case, we have student. This is the class name, and this has simple two properties: a roll number, which is an integer, and then we have age, which is also an integer. That's it. So as we discussed, class is a user defined data type. User defined data type. So at this point of time, when we are defining a class, no memory is allocated in the RAM. Nothing happens. This is just a paper. Nothing physically is happening. But when we create an object, how do we create an object? We simply say student Uday. Now Uday is an object. Uday is a physical object. So physical object will have a memory allocated to it. So this is Uday inside the RAM. And what will Uday have? Uday will have roll number. Uday will have age inside the RAM. So when we defined a class, nothing is happening in the RAM. But when we declare a variable Uday, which is an object, then we will get physical RAM allocation. So this is a simple syntax, right? Just like how we have int a, we have student Uday. So this is the data type. This is the data type, and this is the variable. Just like we have int float char, we have defined our own variable, our own data type, which is student, and the name of that variable is Uday, and Uday will get physical memory address, and it has roll number and age. So since both of them are integer, we get 4 bytes, 4 bytes, total of 8 bytes for Uday. And when we declare another object called the second student Krishna, Krishna will also get roll number and age, another 8 bytes. And then we have Sam. Sam will also get roll number and age. So this is what is happening inside. Okay, but when we declared a class, nothing happened. Okay, that is the paper. These are the actual houses. Okay, so let's try to write this in code to better understand. So I've created a new file, classes and objects. Let's clear the output and everything. So let's quickly get to our template. Okay, we are all good. So let's create our class student, and then we have two variables, um, int roll number and int age. That's it. Simple class. And then we have defined our data type. Now let's define our variable. Now we have created Uday. So in these lines 5, 6, 7, 8, there is nothing happening in the memory. It's a paper. This is the house. When we say in line 10 student Uday, Uday will get 8 bytes of memory. Okay, this has a physical address. Okay, so this is the base structure of a class. And class can also have methods. Class can also have methods. Class can also have methods. So what are methods? Methods are nothing but functions. Methods are simply functions. So when we use them in the context of a class, we call them methods. Okay. So why do we need methods? So now we have two variables inside our class. Class, let me quickly write it down. Class student, int roll number and age. And let's say we have a method that prints everything. So let's say we have a method void print, and what does it do? It prints everything in the class. It prints cout roll number, and it prints cout age. So it's a print method. It's a print method. This way we can have different methods, so we can make use of these variables and use them within the methods to do something. We are, in this case we are printing, we can do other things, we can change the values of these, we can get individual values, and we can do a lot of things. Okay, so let's see how to use this. Let's say we have another method called print, and this just prints it. Okay, so here you will notice that I have used this new keyword called this. So why is this used? So this is used for referring to internal members of this class, so that there is no name conflict. Let's say this print method, let's say for example, it takes integer roll number as input for some weird example. Now this roll number and this roll number are having the same name, right? So when we do cout roll number, uh, we don't know whether it is accessing this or this. To specifically tell the compiler, no, you have to get the internal member of the class, we use this. So this keyword is used for accessing internal members. Okay, so we have, this is the base structure. Okay, so we have um, variables, and then we have methods. Okay, so far we have not run this code because I have not discussed about access modifiers. So let's do that now. So if we have run that code, we would have got some errors. That's why I didn't run it. So when we discuss access modifiers, we will start running that code. Okay, so when we discussed about the oops, we discussed a couple of things called encapsulation and abstraction, right? So this is what it looks like in the syntactical way. So when we say encapsulation, we are having these properties, and we are having these methods, and we need all these properties and all these methods for the student object to run. That is the functionality of the student. So in order to do all this, we put them everything inside a class, right? So we have grouped whatever we need inside a class. So that is encapsulation. Another thing is abstraction. Another thing is abstraction. So what is abstraction? We said we can only expose to the outside world what we want to share. So we discussed about access modifiers using a football example, where I was willing to share my football with the rest of the world. I had no issue, but when I wanted to um, share my computer, I was not so confident. I want to use the computer for myself. I don't want it to be public, right? So that's why we have uh, access modifiers. So by default, everything in a class is private. Everything in a class is private. So if you would have tried to access this roll number outside of class, if you would have said Uday dot roll number, we would have gotten an error because Uday will not have the rights to access this private property. By default, everything is private. In order to enable Uday to access his own roll number, we need to declare it as either public, or we need to provide a public function that goes inside the private variables and gets the value. Okay, there are two ways of doing this. But first, let's try to understand this in the code. So let me run this quickly and see what happens. There will be a couple of errors, we'll fix them. Okay, remember reference point student is a pointer. Did you mean to use this? Okay, sorry. So whenever I use this keyword, the correct usage is to use the arrow operator and not the dot operator. Sorry for that. And let's run it again. So this is the syntax. Whenever we are trying to reference an internal member, we use this followed by an arrow key. Okay. Okay. Now there are no errors. Now if I want to, let's say, change the value of this roll number, I want to say Uday dot roll number equal to 1. Now this will throw me an error. Why? Because it is private, implicitly declared private. So by default, everything is private inside a class. So in order to make this line work, I can make this public. So now all these three, which are all these, sorry. So whenever I say public, whatever is under the public uh, declaration will be public. They can be publicly accessible. So now this line will work because now roll number is public. Let's check it. See, no errors, which means we have successfully changed the roll number. I can do the same thing for uday.age and let's say 10. And because the print method is also public, I can use that to print my values. Now we will see uh, whether these two values are really set. Let's run this. Print declared here. Too few arguments. So no, sorry, I don't need this. I was using this for our example. We don't need this. Oops. Yeah. Okay, let's run it. See, now we have 1 and 10. How did we get this 1 and 10? Let's go through it step by step. In 16, we have declared a student variable and we have assigned uday.roll number as 1, uday.age as 10. These two are public variables, so this line is worked. And we have another function called print, so we are able to do uday.print, uday.print, and inside print we are using this keyword to access the internal member of a class, and uh, that's why this output got printed. Okay, that's how this is working. So this is public, but in general the practice is to make every property as private, and some methods can be used as public. So it's something like this. So I want to specifically say int roll number, int age as private, and I only want to print these values using a public method. So I don't want to expose these variables in private. Okay, let's run this. Now if we run this, we will get an error here. See, declared private. So these lines should not work. We are not allowed to manipulate the values. So we have protected our data members by declaring them as private. Okay. So that's what is access modifiers. So we are able to protect our methods and data members by using access modifiers. So how do we actually manipulate the data then? We make use of setters and getter functions, which we will discuss now. Now in our code, we have, let's clear the output. Now we have roll number and age, and we have a new physical student called Uday. Okay. Now when we do uday.print, there is nothing will be printed because we have not set any values to this. But we want to set those values. We want to give Uday the ability to change these values. So those are setter functions. So how does that look? So this is how it looks. So they're simple methods. So let's say this is set age. Age method will take age as input, and we are accessing the inner member of the class using the this keyword. So this dot age is age. So in this line, this dot age is referring to the variable in line number 8, and the right side value is referring to this. You can also choose to use a different name, let's say age underscore outside value, and you can use this. It works the same way. But generally we don't do that. We try to keep the variable names simple. So this is the setter method. This is the setter method. It is setting a value for a variable. And we can have another method, set roll number, that will also take roll number as an integer variable, and this will set the roll number value. This dot roll number equal to roll number. Here also, when I say this dot roll number, it is referring to the roll number variable in line number 7, and the right side value is referring to whatever is coming as input. Now, what did I do? I have declared two setter methods and I put them under the public declaration, which means now Uday has the ability to set these private members. Okay, let's try to set it. Uday dot set age, age is 10. Uday dot set roll number is 1, and then we will print. So in this line of code, we are passing number 10 to the set age function, and age, this function will uh, allocate the number 10 to this private variable. Okay, similarly roll number, and then we will use the print function to print both the values. Okay, let's see 1 and 10. So we have successfully protected our data members, and we have exposed couple of methods which are in the public declaration, and this is giving the powers to Uday as an object to make those changes. Okay, and common practice is also declare getter methods. These will simply get the values. So I can say get age, and this will simply return the age. I can also have same getter methods for roll number also. Okay, so these two are getter methods. They are simply returning the age. These two are setter methods. They are manipulating the data. Okay, let's use the getter methods also. They dot get age, and because this is returning an integer, I can save it in some variable. In the same way, I can save the variable returned by get roll number function in roll number variable. Okay, and let's say I want to print these as well, just to see if our code is working. Age is age, and line roll number is roll number. Okay, now what should happen? The expected output is we go here uday dot get age. Where is get age? Get age is here, and it returns this dot age. So this dot age refers to this variable age, and we are returning as an integer. So we come back here. So age is getting copied into this age variable, and I am printing it here. Similarly for roll number. Okay, let's run this code. Expected semicolon. I missed semicolon somewhere. I don't see any issue. Let's run the code again. right? So there is no issue. Age is 10, roll number is 1, and this we are seeing because we have used uday.print. Okay, so we have successfully used setter methods and we have successfully used getter methods. And let's try to understand why we need so many methods, and why can't we just put everything in public. Okay, so let's take this code a little bit. Let's take our class. Actually, we don't need it. Let's go to whiteboard. And we already have our structure here. Now we have added a couple more methods: set age, set roll number. Now let's imagine a situation where everything is public. Where everything is public. Where everything is public. Roll number is public, age is public, uh, and let's say we have created our big student application which has lots of features, and we have given it to a friend. We have given it to a friend. Now we asked our friend to make use of this application. Friend will say, yes, I will want to make use of your application, thank you so much. And he will start using it. He will declare his own student, and the student will say S1. And now because everything is public, S1 has powers to change any value. So there's nothing stopping the student S1 from changing roll number to, let's say, 20. And here you will say, yeah, well, what is wrong with that? But if we are not protecting it in a right way, they can misuse it. So there is nothing stopping the student S1 from doing minus 20, right? Maybe S1 dot age is also minus 20, right? Minus 20. Is this correct? Age can never be negative, right? And they have successfully made a change in our class that is invalid. So they have successfully misused our system. So we don't want that to happen. So when we are building applications, we are building it up for external users, right? And users can put any value. So we don't want that to happen. We want to control it. So we don't want to expose our inner variables. But what we can do, we can give a setter function, and that setter function will internally change the value of the variable. But in our setters function, we can control it. How do we control it? So whenever we said set age, and we are passing age here, because this is a method, I can apply conditional logic, right? I can say if age is less than 10, is less than 0, you don't do anything. You simply return, either return an invalid value like -1, or return a string that says invalid input or something like this. We are able to control it. And because we are able to put such conditional statements, our uh, age data member is always having the correct value or valid values. We are able to validate the inputs that are coming in. We are able to check, put uh, constraints that age can only be between 0 and 100. It cannot be 1000 or 2000. It can be never be negative. It cannot be in floating points and things like that. So we are able to control it. That's why we need setters and getter methods. That's why we need access modifiers, so that when we expose this application to public and users will start using it, we don't want them to misuse it. We only want them to use them in the way that we want them to. That's why we put member variables as private, and we put some getter and setter methods, and we want them to use these methods to actually manipulate the data. Okay, this way we can put some guardrails like this. If age is less than 0, return -1. Otherwise, you correctly set the age and you return 0, or you say return 1. So we can have internal function that says if we're returning 1, which means successful. If it is -1, it is a failure. And instead of void, I can simply call this int. So this way I'm able to do stuff and protect my data members. Now I can also have private methods. I can also have private methods. Let's say I have a private method here. Now nobody knows what this private method does. This outside object Uday does not know that there is a private method called a private method. But these guys know it because they are part of the class. These guys can know it. So I can do this dot private method and I can invoke it and I can do other stuff inside here. So these are the inner functionings and outside world does not need to know about all this. So that's why uh, oops gives us so much control over what we can do with our data. So this little piece is called, abstraction. We are hiding away the inner details of our implementation and we are only exposing the things that we need to the outside world. Okay. So those are setters and getter methods. So I think we have covered a lot in this video. We have started with classes, we have discussed the structure of a class, we have discussed access modifiers, public, private, and we've discussed setters and getter methods, and we have understood why we need setters and getter method. Okay, so in any of these topics, if you have any question, please ask me in the comment. I will answer them. And in the next video, we will look at constructors and destructors. Okay, that is also a very interesting topic. Okay. So thank you so much for watching, guys. Please don't forget to like the video and bookmark the playlist. And if you have any questions, do leave it in the comment. Okay. I will see you in the next one. Thank you. Cheers.